Okay, great. Hello, everyone. I'm happy to present our work on ZePHyR, zero-shot pose hypothesis rating. So 60 pose estimation is about obtaining the translation and rotation of the object relative to a known frame. It is particularly useful in many object-centric planning algorithms. Given an observation of the scene, we can first estimate the 60 pose of this object, and then we use planning algorithm to perform a post-relative action on that object, like grasping here. So traditionally, for this pipeline to work, object-specific post estimator must be trained. This involves defining the object, annotating a large amount of data set, either through simulation or human annotation. Then a set of network weights are learned to estimate the pose. This process is then repeated for every object you plan to interact with. This results in excess effort in collecting the data set, excess time in training networks, and excess space to store the network weights. So to solve this problem, we propose ZePHyR for zero-shot pose estimation. Zero-shot pose estimation problem seeks to generalize between seen and unseen objects. So we use label data to learn the algorithm that can be extended to novel objects without the need for new labeling or extra retraining. Our approach to zero-shot pose estimation problem is as follows. First, we obtain a point cloud model of the object. Then use observation. We find many possible pose hypotheses. And then we score each of them according to its fitness and select the best pose to be used in a downstream task. The primary focus of this work is on how to accurately score this hypothesis. So given an observation image and the object model, we estimate a set of pose hypotheses using the observation data. In our case, we use hypotheses generated by point features, but any pose estimation method will work here. These hypotheses are then compared to the observation using the project model points. And then simple distance functions are used to produce point difference features. These point difference features are then processed by our score network, which is PointNet++. Then it produces a score for each pose hypothesis. The maxima is the most accurate object pose. So to evaluate our method, we use two standard pose estimation datasets, recipe video and line model occlusion. So we split the object sets in halves, training the object on one half of the objects and testing it on the other. So for recipe video, we trained and tested two networks on complementary object sets. And on occluded line model, we train the network on the line model objects that are not in the occluded set and test on the remaining objects. So in terms of results, we can see that by applying our scoring function on the point pair feature baselines, we achieve a 50% improvement on the unseen recipe objects. This also outperforms all other zero-shot methods. We see similar outcomes on occluded line model, achieving a 13% improvement over the baseline method. Also, as a reminder, our method is not trained on these objects. So here are some qualitative results on occluded line model datasets. And we can see that our method consistently improves. On recipe video, our method can effectively solve the geometric symmetry. So in conclusion, in this work, we present a zero-shot method for scoring pose hypotheses. We show that through the use of point difference representations, we are able to accurately estimate pose. And we exceeded the performance of other zero-shot methods on two major data sets. We would like to thank the sponsors and welcome any questions.
Thanks, Qiao. If people have any questions, please type in the chat or raise your hand. I have one short question. So during testing, right, do you assume you have segmentation of the unseen objects or unknown objects? Then you can generate your pose hypothesis based on the segmentation.
No, we do not use any detection or segmentation results. We run the point pair features on the entire scene, and it will will give lots of hypotheses, and we scores through all of them. Yeah.
I see. Thank you.
You're welcome.
Okay, then let's move to the next talk. Thanks, Qiao.